Suppose you need to know an equation of the tangent plane to a surface S at a point. Specifically here we're going to look at the point 213. And you don't have an equation for the surface, but you know that there's two curves. I'm going to call this vector function r1 of t, a curve, and r2 of u, another curve. And both of these curves are actually on the surface S. Now find the equation of the tangent plane at P. Well, if I can find a point on the surface, and if both of these curves on the surface pass through this point, then finding the tangent at that point in reference to this curve and the point tangent at the same point in reference to this curve, both these tangent lines will actually be on the tangent plane. So then all I need is find the cross product to find a vector that's normal, and I have a point, and bam, I'm there. I've got the equation of the tangent plane. So first thing I need to do is I'm going to take the derivative. I'm going to take r prime 1 of t, which is going to be, let me see here, 3 minus 3t squared minus 4 plus 2t. And r2 prime of u is going to be 2u, 6u squared, and 2. Now note here that when I look back at this, I need to figure out where R1, or does it go through this point or not? And let me see, what can we do here with this? Sure enough, at 0, R1 of 0 equals 2, 1, 3. So when t is 0, I'm at this point. Now R2, I need to take a look at this, and really the easiest way to do it, I'm going to take this, say 1 plus u squared has to be equal to 2, because I need to be at that point. That would then imply, obviously, that u equals 1. So when u equals 1, what is everything else? I get 2. When u is 1, I get 2 minus 1, which is 1, and 2 plus 1, which is 3. So when u equals 1, it goes through this point. Well, that's good. So now when I take these derivatives, I can evaluate the derivative functions, this one at 0, this one at 1. And when I do, r prime 1 of 0 equals 3, 0, negative 4. R prime 2 of 1 equals 2, 6, 2. So I know both of these vectors are going to actually end up being on the tangent plane. That's a good thing, because now what I need is that vector that's orthogonal, that's normal to the plane. So all I'm going to do is take a look at r1 prime of 0 cross r2 prime of 1. And I'm going to set that up. That's going to be equal to, I'm going to do the determinant I, j, k, 3, 0, negative 4, 2, 6, 2. And that determinant is going to be, let me see here, 0 plus 24i minus 6 plus 8j plus, sorry, ran out of room again, 18k. So a vector normal will be 24, negative 14, and 18. Now, I can work with that, or if I want to simplify life a little bit, I know that right away I can take 2 out of each of these. So this is the same as 2 times 12, negative 7, 9. The number's a little bit smaller. If this is normal, then this will also be normal. So you can use this, or you can use this. You can simplify, whatever you want to do. So I think I'll go ahead and I'll stay with what I originally had. It's not that big of a deal. So what I'm going to do is I'm going to take, 24, negative 14, 18, dot x minus 2, and see, y minus 1 and z minus 3, and that has to be equal to 0. Make sure I've got 2, 1, 3. Yeah, 2, 1, 3 is the point that I need. So that is going to end up giving me, see, 24 times x minus 2. Negative 14 times y minus 1. And, oops, that's not a comma. This is a dot product. So this could be plus 18 z minus 3 equals 0. And that was kind of ugly, so I just want to fix this a little bit. And then simplify this thing, and you end up with your equation of the plane.